Good morning, children. Children, as you all know, we are studying topic metallurgy, and in this topic we have already discussed about the metallurgy of the moderately active metals, or I would say we have explained you the steps involved in the extraction process of the moderately active metals like zinc, iron and manganese. Children, today we are going to discuss the extraction of two metals which are mercury and copper from their ores. As you all know, these two metals are less reactive metals and placed low in reactivity series. Children, uh, mercury is generally extracted from its sulfide ore, which is called as cinnabar. Copper is also extracted from its sulfide ore called copper glans. Let's start from mercury. Mercury. Mercury symbol, you all know, it is Hg. It is the metal which exists in liquid state. Just now I told you mercury ore is cinnabar and this is the sulfide ore. So I can say its chemical name is mercuric sulfide and its chemical formula is HgS. So we are going to take here mercuric sulfide or HgS, and we are going to convert this HgS into pure Hg or mercury. Now, children, in last topic I told you every ore has to be concentrated first, and concentration is entirely depend upon the physical properties of the ore as well as the gangue particles present in the ore. Here cinnabar will be taken and it will be concentrated first. When the ore is concentrated, we will get the ore which is sandless, mica-less or rocky particles, earthy particles less ore. And when we get concentrated ore, we'll be having next step which is called roasting in case of cinnabar. Children, mercuric sulfide exists in the solid state. As you are seeing on the screen, step 2, I am showing one reaction where mercuric sulfide is taken in solid state and it is roasted. Roasting term I described you in last video that roasting is the process where generally sulfide ore is taken and oxygen rich air is passed over it and it is strongly heated in the presence of oxygen rich air or in the presence of oxygen. What will happen in roasting process? This sulfur present in any sulfide ore turn up into sulfur dioxide and escape from the ore, whereas the ore will be converted into its oxide. Now children, as you are seeing on the screen, this mercuric sulfide is also roasted and this mercuric sulfide is turning up into mercuric oxide and sulfur dioxide, because it is forming in a gaseous state, will escape from the furnace where the process is going on. Third step. Third step of this metallurgy is this mercuric oxide which is formed after the roasting process, this mercuric oxide will be taken and it will be strongly heated at 300 degrees Celsius. When it is strongly heated at 300 degrees Celsius, this mercuric oxide will be decomposed to give you mercury metal, and oxygen will be escaped in a form of oxygen gas. Now, another less reactive metal, and it is copper. Symbol of copper is Cu, and this copper, one of the ore of copper is copper glans. In earth crust there are so many ores of copper, and we are learning the extraction of copper from its one of the ore, and which is copper glans. Again children, this copper glans is a sulfide ore. Sulfide ore, and its chemical name is cuprous sulfide, and its chemical formula is Cu2S. Children, if you are noticing here cuprous form is shown because cuprous sulfide, I told you the chemical. That is why its chemical formula is Cu2S. So, this Cu2S will be taken, and let's study the steps involved. First step, again I told you, any ore will be coming from earth crust has to be concentrated first. So this sulfide ore will also be concentrated, and method will be employed on the basis of the physical properties of gangue and the ore or the copper sulfide, and after concentration process we will get concentrated ore, which is minus gangue particles. Now this concentrated ore will be taken, and step 2 will be employed, which is called as roasting, because it is sulfide ore. So again this copper sulfide will be roasted, or it will be strongly heated with oxygen rich air, where oxygen will remove sulfur from copper sulfide to turn up into copper oxide, and sulfur will escape as sulfur dioxide. As you are seeing equation of step 2 on your screen, which Cu2S is reacting with oxygen to give you Cu2O. Children, here you need to concentrate. Cuprous sulfide is oxidizing to give you cuprous oxide. Generally children do mistake by writing, instead of Cu2O they used to write CuO. Avoid this mistake, and cuprous sulfide will be turned up into cuprous oxide. Now children, please hear it again. The process is going on, and this process is going on in one of the furnace, and what happens when 50%, approximately 50% copper sulfide is turning up into copper oxide, the supply of oxygen will be stopped. If the supply of oxygen is stopped, that means copper sulfide will stop turning up into copper oxide. So what will happen? Inside the furnace there is the mixture of copper oxide and copper sulfide. So both the compounds will react with each other, and they will give you copper, and sulfur dioxide will be escaped. What I am saying here, please hear it again. During roasting process, when the 50% of copper sulfide is converted into copper oxide, the passing of oxygen gas or the supply of oxygen or air will be stopped. Now, in a furnace, 50% approximately copper oxide or 50% copper sulfide is present. Both will start reacting with each other because already the temperature of reaction mixture is quite high and start turning up into copper and sulfur dioxide escape. And after this reaction, we obtain copper. And generally, if you hear children, after this reaction, we used to get copper, which is also called blister copper. Why? Because on the surface of copper, there are small blisters which occurs because of the escaping of sulfur dioxide. Okay, children, this is all about the extraction of copper and mercury. Hope you understand.